Good morning for most everyone. Welcome to Energeia's webinar on breaking the charging barrier to EV adoption in Australia. My name's Ezra Beeman. I'm the Managing Director, and I'll be walking you through the material today. I want to say thank you for everybody for setting aside some time for what I think is a pretty important topic. We have to get this right if we're going to unlock the electrification of transportation in the timeframes that we need to. A few housekeeping matters before I get started. One is please type any questions you have in the chat. There'll be a period at the end of the presentation to do Q&A, and by typing it in early, you get your question answered early, but also allows us to organize them a bit more. The other thing I would say is that a link to this webinar will be provided at the end, along with a link to the presentation, and you can find our previous webinars on our website, which is where you can also learn more about the business. Okay, well, let's get started. So today we're going to cover, first of all, defining plug-in electric vehicle charging infrastructure, or PEVs. Some folks may be more familiar with battery electric vehicles, or BEVs, or plug-in hybrid electric vehicles, PHEVs. PEVs really just combine those terms. Anybody who actually needs to charge. 2, how much infrastructure is actually needed. 3, our approach to sizing public charging infrastructure, which we've developed over the course of at least 10 projects over the last 5 years. One of the most important parts of the methodology is segmenting drivers to ensure that the infrastructure is fit for purpose and least cost. And then defining, identifying, and assigning charging solutions. And then a look at the infrastructure costs and cost per driver per year, which is often a very surprising outcome for folks who haven't been deep in the numbers. And then finally, our methodology for optimizing that infrastructure and ensuring we provide equitable access at lowest costs to all drivers. So first of all, I'd just like to talk about the different kinds of charging. So the first way we break it up is by location. Is it private, i.e., only certain people can access it, or is it public? Anybody could, in theory, access it. Now, some things are semi-private, and I'll get onto that in a moment. The second way we segment it is by type. So level 1 charging is really just plugging it into the wall socket. Level 2, you need a special socket, usually something similar to your dryer or your electric stove at home. That's called level 2, and it can range between 7 kilowatts and all the way up to around 24 kilowatts. And you have level 2 at both public and private charging locations. And then finally, you have level 3, also known as DC fast charging. That's the fastest way to charge. It goes all the way up to 350 kilowatts at the moment. And most of those chargers are software upgradable to 500 kilowatts. It's really just the vehicle that's the limiting factor. Now, here we're defining the applications for these different types of charging, and you can see the private could be your home, it could be your workplace. DC fast charging is usually used for heavier vehicles, including buses. On the public charging side, that could be curbside charging, or what's called destination charging, places you want to go, things like where you shop or where you go to the movies. For DC fast charging, that's usually applied if you need to go on a very long trip that's beyond the capacity of your battery. It can also be used for primary charging too, and we'll get onto that because it's one of the areas we think is most prospective. In long-haul trucking, you just have a lot of power that you need to get in a short period of time. It's really important that all right, I was offline for a second there. Apologies. I'm saying DC fast charging, usually used for range extension on long-haul trips. Or for heavy long-haul vehicles like long-haul trucking. They may be subject to a range of rates or tariffs. One thing we'd like to highlight here, if you're going to do controlled load, usually it doesn't work as well on the public charging infrastructure because a lot of times the business objective there is really to charge vehicles, and controlling that load or managing that load is going to be a lot more difficult. Right. So the way that we size public charging infrastructure, first is we take into account potential charging locations. We get these through a mix of data, usually geospatial data. We have researched charging preferences. If you have a choice between charging at home or charging at work, what the preference would look like, what the segment characteristics are. Are you mostly at home, mostly at work, mostly at school? Do you own your home? Are you renting? Because that's going to limit what sort of infrastructure you might want to pay for and you could be allowed to install, how many vehicles there are at the home, because that will often drive how many are going to be conveniently able to be charged, and how many might actually be more conveniently charged at an alternative location. How many EVs could actually charge at that particular site? So if you're at a parking lot, you may be able to charge 20. If you're at home, maybe 2 to 3 at most. What is the power of that infrastructure? Because the faster you charge, in theory, the more vehicles you could charge over a given year. Once we put that into our charging model, that also tells us how much it's going to cost, both in terms of capital as well as operational costs. We take in things like the equipment costs, what the electricity rates are, and that can be quite an important driver because over its lifetime, most of the cost is going to be in the energy most of the time. What the assumed utilization maximums are, because that drives how many chargers you need for a given fleet, the efficiency of that charging, and locational setting. So that's the approach we use. And it's easy to put it in boxes, but there's a fair bit of effort that goes into determining that for a particular location or jurisdiction. So I won't spend too much time on this. Anybody on this call will hopefully have seen something like this before. Again, I already talked about the different levels of charging. I think the thing I would draw your attention to here are two on the horizon technology. One is wireless charging. They're able to recharge vehicles with relatively low losses, somewhere between 5 and 10%, depending on what the gap is. You could be stationary or moving. And at the moment, we're seeing charging rates of around 11 kilowatts, so already faster than level 2. Now, there's a number of benefits from wireless charging, including potential safety because you don't have the contactors, maintenance because the contactors don't wear out. But most of all, the biggest benefit is convenience. If you don't have to plug in at all, then wireless is going to be the most convenient way to charge possible. And so that's one of the key reasons we expect it to be the dominant charging technology in the longer term. The other important charging development is vehicle to grid or vehicle to home. And that allows you to not only charge your electric vehicle, but to also discharge your battery into your home or into the grid, and that can help you balance your charging at home. It can help support the grid. It can help support the market, but that's still in the early phases. So one of the important things to look at when sizing infrastructure is exactly how much infrastructure is going to be needed. Now, here we're showing trends in range extension, and what we've plotted here is the typical miles of 3 of the most popular cars. And you can see some of these cars, like the Leaf, have started at less than 100 miles and are now over 200 miles. The Chevy Bolt started out higher and hasn't moved quite as much, and you see the Model 3 has moved a bit. Now, ultimately, particularly for passenger vehicles, we expect the range to approach or even to match in terms of combustion engines. It costs more to the car because of the battery, but there's a lot of benefits. And as these batteries get bigger, your need for range extension charging, which I mentioned previously, is going to go down. It also means when you have a bigger battery that on average, there'll be more flexibility in when you charge for flexible or smart charging opportunities, and also for vehicle to grid and vehicle to home. The other thing we would note here is the rate of charge for DC fast chargers at level 3. And here you see that when they first came out in 2011, it might take you 70 minutes to recharge a battery of a particular size. Now we're sort of down to 10 minutes. And the classic approach, the classic metric is you can charge 80% in 20 minutes, and that's going to go down to 10 and 5. And ultimately, we also think recharging is going to get about as fast as a gas station experience, just because people are familiar with that. They like the convenience. And ultimately, that's where we see it going. Now, to the extent you charge faster, you also need less chargers because you can put people through the forecourt faster. So we keep track of these, and this factors into our sizing estimates. Now, what do other people say is the right level of public charging infrastructure? Now, you'd think there'd be a lot of research and a lot of reports and studies out there that you could point to and know, well, I know I need exactly, one charger per 5,000 people or 5,000 drivers. But the truth is, there are very few studies that have been completed. The ones that we found recently are listed here. The California Energy Commission has done one recently. The International Council on Clean Transportation has done one a little bit longer ago. NREL for the North America has done a comprehensive study, and they've got a tool called EV Pro that if you tell it sort of where you are based and how many vehicles you want to serve, it gives you load profiles and estimates. But we've not been able to find a lot of detail on how those estimates are actually developed. Now, what's interesting from this graphic here, you can see that when it comes to the charging mix of public and semi-public, that the California Energy Commission and NREL are expecting most of the charging to occur using level 2 chargers at the workplace and in public, and only a very small number of DC fast chargers to be used. The ICCT, on the other hand, sees about half of charging to occur using DC fast charging, which is a lot closer to our estimates, as you'll see, mainly because of their cost effectiveness and their flexibility. Now, we also brought in two big consulting firm brands, BCG and McKinsey, and you can see they've got very different views of the world. BCG is seeing a lot, particularly mixed between public and private, where about half of the charging will be public and private. Now, keep in mind, this is Europe, and they have a different sort of mix of on-street parking and density. And McKinsey's is from North America, and you can see they're pretty much assuming that by 2030, 90% of people are going to charge at home, which again, you look at, I couldn't really find the detail there. I think from memory, it's really due to the significant costs that they have identified outside of the home that is driving this outcome. So we're gonna share with you our approach, and we're gonna be as transparent as we can about our assumptions. And hopefully you'll either agree that we got it right, or you'll come back to us and point out where we don't, because at the end of the day, we're just trying to do the best possible job. What's really important is that we get this infrastructure out there at the lowest possible cost and make it accessible for everyone. So how do we do that best? So the way that we approach it, first of all, if you look at this top graphic, you can see here the percentage of trips that are between 0 and I think that's miles. So everybody's gonna have to do the analysis in their head, but we've done this in a number of Australian states. There's good origination and destination data in most states. This just happens to be from North America. The vast majority of trips are less than 10 miles here. Some are between 10 and 50, but only a very small fraction, 3% is greater than 90 miles, right? And so that you have to be over that to really actually need distance charging if you didn't charge up at home. That particular charging is what's going to be served at the moment by DC fast charging. The rest of this is currently, in most jurisdictions, thought to be done through level 2 charging. Now, you can see it's broken up by dedicated, owner-dedicated charging, owner non-dedicated charging, and renter charging. And the reason for that is really an assumption about who's got access to guaranteed dependable charging at home. Because if you don't have access to that, then you're going to need some kind of public or semi-public solution. Otherwise, you're just not going to buy a vehicle and hope that you somehow come across a charge plug. It has to be there. It has to be dependable. So in our approach, the first thing we do is figure out, well, how many people are pretty much guaranteed to be able to charge at home. We look at how many people live at the average home. We make an assumption that one person at least is probably going to be able to access a port at relatively low cost. Now, you can share chargers. You might have multi-car garages. Our presumption, though, is those often are cluttered. It's not impossible, but on average, we just have made a conservative assumption of one. That's this green bar here, non-dedicated charging. Everyone else, if you're a renter, longer term, all houses will probably have home charging. But in the next little while, we're assuming if you're a renter, you're going to have much higher barriers to installing level 2 charging. And when you have a bigger battery, level 2 charging is really important. If you come home and you've got an 80 kilowatt hour battery in a typical new Leaf, it's going to take you like 24 hours to recharge. So you really need that level 2 charging. The other folks are the non-dedicated charging. So you own your own home, might be your child, might be a roommate, but to try and share that charger, they're probably, if they had an option, would go for a dedicated public alternative. Now, when we split these folks into exactly what kind of drivers they are, and we do it basically by where they're likely to spend most of their time. You can see here, full-time college, not full-time driver, sorry, not full-time college or or work. We've got full-time work locally, which is the purple, and then full-time commuters. And these all have implications for the kind of infrastructure that is best suited for them. We'll get on to that in a second. And I say I've got a question here. Thank you. We're going to just wait to the end and take them all then, but please do keep them coming. So if you were to then apply those segments to a forecast of vehicle uptake, you can split that population. And these are just the folks that need public charging infrastructure. And I believe this is work that we did on behalf of San Diego. You can see there that that you got to put the charging infrastructure in certain places. It's no good trying to have full-time college students charge maybe downtown where at retail centers or work, and likewise putting them at colleges, universities, and even high schools is not going to serve the needs of full-time work locally. So having a good understanding where these cars are going to spend most of their time is really important. You can see here that the split basically on how many of these folks are dedicated versus non-dedicated, and then finally splitting it by how many people actually, or how much driving is going to be greater than 150 miles, which is a small fraction, right? So if this was just DC fast charging targeting long distance travel, you'd only need a small fraction of them compared to charging done for level 2. But we see things a little bit differently, and I'll get into why. So in terms of how can we actually provide service to these drivers in a dependable way? Again, I want to emphasize, until there is dependable, guaranteed charging options for people that can't otherwise charge at home, they're not going to buy vehicles. So what are the solutions that are possible? Now, here we define solutions as a combination of a location and a charging technology, level 1 or level 3, really, DC fast charging. Now, the way we define solutions in terms of figuring out where they are across the jurisdiction, how many of them there are, and what is the ratio of potential locations to potential drivers, we come up with characteristics and specify each of those locations. So for example, here, you can have business curbside charging in a business district. You can do it in a residential area. And we calculate how many of those potential sites there are. We calculate what are the typical hours of usage, because that's going to define hours of usage, what people would use them, and how many hours a day there is. That tells us basically the maximum vehicles that they could service if you were being efficient. Now, we assume people are not going to be efficient, but you got to start somewhere in terms of what is the total number that would be required for a given number of drivers over time, spread across the jurisdiction. We've got some definitions here as to how we get those locations. And down here, I just want to highlight that if you're not going to have it be like where you mainly work or mainly go to school, but it's going to be a destination charging, depending on how often you visit it and how long you stay there, it sort of tells you what kinds of drivers that it could actually serve the needs of, right? So here you go once a week and you're there maybe for an hour or two, you could only serve drivers that only do less than 20 miles a week, et cetera. So I think I'll let you review that in your own time, but that's the kind of thinking when you're matching up driving behavior and driver needs with potential solutions. And a lot of people are surprised to learn that just putting it in like grocery stores is not really going to do the job, except for a small fraction that don't drive that often. And that most of this has to happen close to work, close to school, or home if you're semi-employed or no longer employed or retired. So some examples just visually: multifamily dwelling level 2, curbside level 2. Here's some destination charging, parking lots with level 2. Here's business curbside. Looks like a nice location there, nothing but Teslas. Then we have hotel level 2, solar level 2. So these are, I think people underestimate the need for charging at accommodation. I mean, people are traveling. This is an opportunity for them to charge in between their trips. They're almost by definition away from home. And there's going to be a need here. And this is a project that we were lucky enough to work on in South Australia, where they did recognize this need. And the work that we did there with our partner really mapped out what that looked like from infrastructure requirement, cost of service perspective, and from a grid perspective. Increasingly, you're seeing solar co-located along with batteries to help defray some of the costs. Here we've got DC fast chargers also in destination locations, and we're seeing a lot of these pop up in our Davis office location, and I'm sure they're popping up all over Sydney as well, and Australia for that matter. Right. So with that in mind, I want to sort of give you the visual of how we then situate potential charging locations, and also the need for these chargers. So what this has done, this is in Fresno, which I happen to be in at the moment. And you can see here, what we've done is we've laid out a grid, and that grid is 200, it's a 400 foot by 400 foot grid. And the reason for that is based on some research that was conducted around willingness to walk for doing shopping. Basically saying that you can, as long as you situate the charger somewhere in this 400 foot grid, it could serve anyone who's within that grid in a reasonable way. And you can see here, what this is basically saying is there's a whole lot of folks, because of residential dwellings, where there is a very low density, and only a few places where you've got significant multifamily dwelling complexes, and yet we have to serve all those folks, either where they're home or where they work or where they go to school. And anytime anybody doesn't go to school or doesn't work, then it's got to be out in their community, or it has to be some alternative, like maybe at a gas station they drive by. And so really thinking this through is really important, because to the extent that any population is not being served, it's not going to buy an EV, and we won't achieve the targets that we've set ourselves. Now, if you look at this in terms of the business locations, right? So if you want to try and serve folks that are going to be at work all day, this is really where you have to put the infrastructure. Now, it's a lot denser than we saw the residential. So if you're a full-time worker, it's a lot easier to target making infrastructure available for you to have an electric vehicle. The retired folks or the unemployed, which may not be buying an electric vehicle first off, that's going to be more challenging, is what this is telling us. Now, the third way of looking at this is gas stations and parking lots. Now, this is where you're more likely to see the DC fast chargers. We've also included the high voltage network, because if you're going to put in DC fast chargers at 350 kilowatts each, there's a capacity challenge that needs to be addressed. So if it was easy, we'd all be doing it right. But this is definitely some of the way that this infrastructure and the planning of this infrastructure need to be understood in order to effectively develop and design one of these infrastructures. So how do we do it? All right, so as we had before, here's a breakup of all of the different drivers. We then map how these drivers could be served. And so anytime, like full-time college students, as I was saying, they could be served by a college location, but they also go home, right? And they could be served by multifamily or curbside. These are potential solutions. Technically, they could also charge at community centers and parks, but unless they go there a lot, it's really not going to be enough hours for them, and they could be served by the DC fast chargers. And so when something's green, we've determined it is the preferred option because of either convenience or cost. Largely cost in this example, but we have clients that for a number of reasons, cost won't be the most important thing. Right. Okay. So so we talked about cost. Now this graphic, I got to explain a couple of things about this. So the way that we come up with the costs per the solution per EV per year are, we first look at the the capital expense, the investment required. And so for a DC fast charger, that might be 150,000, 200,000. I don't have the slide here, but it's a lot of money compared to a level 2 charger, which might be between 5,000 and 8,000, depending on how much trenching you have to do. Now, so a lot of folks say, oh gosh, well, we will need to do level 2 because that's a lot more cost effective. But the thing you have to understand is the watershed, how many people could it serve? And I'm just going back here, apologies. The watershed of how many people could it serve, as well as how fast can it serve them. And that then drives utilization or expected utilization. And solutions with a big watershed, like a gas station on a busy road, could potentially serve a great many cars, and it can serve them really quickly. So you can take a something that's 10 times more expensive, but if the utilization on it can be more than 10 times higher, then you've got a cheaper solution. And that's what we're seeing in the numbers when we do them. And that's been a big surprise to a lot of folks, that DC fast charging is actually, depending on the assumptions you're making, more cost effective. And so you can see just on CapEx of and OpEx of the equipment itself and installation, it's by far one of the cheapest. Things that are higher cost are up here. And this is things like workplace. And people say, well, gosh, we're putting a lot of infrastructure into workplace. And there's a good reason for that, because people are, they're interested in giving it to their employees. But for most businesses, they're not serving a lot of folks. And they might have a parking spot or two. And maybe, if it's a small business like ours, maybe 10 people in the office. And so there's not a big watershed. And so if you don't have a big watershed and one person in that office has an EV, it's a relatively high cost solution. Whereas if you put a curbside charger in between 4 apartment complexes that any of those 4 can use it, you can see that the utilization on that could be much higher. And then DC fast charging higher still. Now, the question is, well, what about electricity costs? You've got to pay demand charges. Yes, but you're generally connecting at the high voltage level. And so you don't have to pay for the low voltage equipment. There's batteries. And a lot of the analysis we've seen and we've done suggests that they're actually cheaper in terms of cost to serve, depending on what the load factor is, what the peak demand is. And because they can be more highly utilized, that load factor is actually looking pretty good. Okay, so once we look at all the drivers that need a solution, we look at the different solution types and options. We do the initial mapping of drivers to solutions. Then we actually have to come up with an estimate of what we think the allocation is. I guess on our the cutting edge modeling, we are starting to look at people making economic and other decisions. But for now, it's a top down based on this analysis. Here, we give an example of a pro rata allocation where we're just allocating infrastructure based on the total number of sites. And you can see that places like workplaces and business curbside with just more spots, and so they've got a higher allocation. And then we do an allocation between level 2 and level 3, and that gives us this pro rata allocation. Then we do here an optimized, just to show you the difference. Now, the difference between optimized and the regular is that there's a lot more DC fast charging because we've just shown you it's a lot more cost effective, and it can be situated so you can equitably and fairly provide access to a lot more people. And then within each of these subgroups, and the way it works is you have to allocate between level 2 and DC fast charging. And then with each of these groups, you have to allocate 100%. So within the school group, 100% goes to schools. Within the people charging at the workplace primarily, half go to the workplace, half go to the parking lot. None go to curbside in this particular case. And that reflects maybe that curbside's at a premium. Our client doesn't want to really consider that for various reasons. And then multifamily versus res curbside, we put it all into multifamily again. Even though curbside can be more cost effective, multifamily can be easier in terms of having volunteers. You don't have to deal with permits, at least you don't have to deal with the curbside charging issue. All right. Oops. So when we do the numbers, and we identified based on that uptake forecast, which is by driver, which is here, what we see is to make sure that you've got enough infrastructure for everyone. Whoops. Here we have the total chargers needed, and we break it up, and we show you basically by what kind of charger. And you can see here there's a lot of multifamily, there's a lot of workplace. This is the optimized design with a lot more level 2 charging. And this is the unoptimized design. And although they start off pretty well similar at the beginning, and that's really for the coverage. You got to start with coverage. Again, if you don't have coverage, then not everybody can access it. So our forecasts and our designs start a lot more front-ended than any other ones we've seen, and it's really for access. But then on the optimized design, because a lot of that growth is being handled by DC fast chargers, you just don't see the increase in the number of hoses required. And that translates directly into costs. And so the difference here, just between the high-level analysis we just walked you through, that the optimized design can be less than half the cost of the unoptimized design. And we could go lower still if we really wanted to focus on the cheapest rather than considering other drivers of the design. Now, when we lay this out, in this case, we don't prescribe that it should be on that corner or that corner, but we basically say, look, within this rough spread, you need to install this amount of chargers of this type within this time frame if you want to remove charging infrastructure as being a barrier to uptake. Now, where that actually goes can be reactive. Somebody puts their hand up and says, I need a charger. If there's no charger there at the moment, then a charger gets put in. That's a model that has been implemented successfully in the Netherlands. Or you can put them out prospectively but they generally have to be spread, and then you've got the advantage of making it more publicly obvious that there will be this infrastructure for folks to rely on. All right, well, that was a whirlwind tour. Questions. So let me start at the top. From David, thank you. In some suburbs, there's a lot of private off-street home parking where charging can occur. In other suburbs, there's hardly any opportunity for off-street home parking. That must make a significant difference to public charging requirements. The suggestion that 90% will charge at home, does that mean EVs will really only be used by those with off-street parking who can charge at home? I mean, to me, I don't see how 90% of people can charge at home. It implies just so much access to the electricity system, like where those chargers are going to go, that you even have a place to park. So I don't know, maybe that included off-street parking. I don't want to sort of put words in people's mouths. But yeah, for the reasons we just laid out, we see home charging, being the easiest and best thing for those that are privileged enough to have a place to charge at home and have the money to invest in a charger. But for most other folks, it's going to be a private or public or semi-public alternative. Peter, you mentioned the added charging flexibility of EVs with larger batteries. Do you think the EV fleet could deliver a portion of the longer duration storage needed to get through cloudy, low wind winter weeks by gradually running down average state of charge of the fleet? Obviously, owners who need their 50 kilometers full charge still need that delivered, but many may be able to work with a gradually reducing charge for those few weeks. Look, we have a long way to go with maturity on people's views, but we really think that electric off-peak hot water is a good model here. That model has been so successful because people trust that they're going to have enough hot water to do what they need to do. And if they don't, they call and the system's got a way to charge it up instantly. But vehicles, once the analytics get good enough and they're integrated with your Outlook and all the rest of it, there's an awful lot of spare capacity. Like it's an unreal amount of batteries that are going to be running around, and they are going to be 90% not utilized because most folks do not drive 300 to 400 miles a day or 400, 500 kilometers, and all that capacity could be used doing something else. But we have to get comfortable with that. We have to have the unleashed, and almost as importantly, we've got to have the price signals, and all that is under development. All right, Paul, what insights do you have about fleet charging in Australia and US? What mix have you seen between home, depot, and public charging? How are costs modeled with a mix of charging options like this? Well, so we have two major fleet projects at the moment, to the extent that we're doing a combination of web scraping, we're doing interviews, we're doing GIS analysis, and it's been really interesting. We've got a lot of insight into how the different fleets operate. I mean, regardless of whether you're an LGA or you are a logistics company, people buy certain vehicles because they have certain uses for them. And what we're finding, for example, is the long haul reticulateds, they're mainly going to recharge at truck stops. And there's a great database of where those truck stops are. Rigid vehicles probably going to charge. They're going to come back to base most of the time, and they're going to charge at their depot or their fulfillment facility, etc. People generally don't park those at home. Then you've got big fleets like ambulances, police vehicles, specialty cherry pickers, etc. And generally those are also not parked at home. So it really depends on the vehicle, and in a given organization will have some of their vehicles that are parked at their depots, some that go home, and just the whole how are they sort of dealing with the leasing and the charging costs. That all is being worked out, and it just needs to be done. I don't think it's all that difficult. The main challenge, I think, is all of a sudden having a bunch of vehicles that didn't need the electricity system before, and ensuring that the utilities are planning for it. And so it's great to see the utilities that are reaching out to their fleet customers, that are trying to reach out to them and having those discussions, because all of a sudden, each hotel that's got 5 or 6 cars really needs 5 or 6 level 2 chargers at a minimum, et cetera. So it's a huge opportunity. It's one that's coming probably faster than passenger vehicles, really, because as the economics and availability get there, it's a no-brainer that you transfer to the cheapest thing, as long as you have the same level of service. All right, Peter, so you don't see the added battery degradation of DC fast charging reducing its use except for long trips. So a couple of things. One is we were really interested to see that, at least in our review of vehicle to grid capable vehicles, there was no language there restricting how often you did vehicle to grid. So the businesses must have put enough excess capacity, or they're going to deal with it through some kind of service option. I'm not sure, but they certainly aren't delineating that for vehicle to grid. And the life of the battery is really a function of depth of discharge and heat, and also float and a few other things. So yes, the DC fast charging is going to generate more heat and is going to be tougher on the batteries. But so far, first of all, in the electric vehicles I've driven and in the research we've done, nobody says, hey, you only get half the warranty if you go to a DC fast charging place. Maybe they will if everybody starts doing it. I don't personally think it's going to be that big a deal in the grand scheme of things, but you never know. Okay, got one from John. Would reconfigured petrol stations really work for EV chargers, given the petrol stations are built for rapid filling of cars, say 2 to 3 minutes max, versus charging minimum 10 to 15 minutes? Look, I think that's a very fair point at the moment, although I have timed myself at the gas station, and you have to be really quick to get in there in 2 to 3. Like, it has to be nobody else there. You pay at the pump. I mean, I think a bit longer is not that uncommon. But certainly you saw that graphic of how fast the DC charger is going. And right now at 350 kilowatts, we're looking at, maybe 10 minutes to 80% full. The other question, do you have to get to 100% full? Or is 80, you just keep charging up to 80% because A, it's better for your battery. And if you've got a 100 kilowatt hour battery, maybe that's good enough. But I expect that we're going to get 1 megawatt chargers, and then the technical capacity will get you out of there in 2. Can change the energy. It says I've lost connect. Oh, I'm back. All right. So Paul, V2G can change the energy cost equation for the home or workplace, reduce energy from the grid, participate in energy market. When do you see this becoming important to modeling costs of charging infrastructure? We think it's important now, and in some of the work we're doing, some of the most exciting work we're doing at the moment is vehicle to home algorithms and vehicle to grid algorithms, just because having 80 kilowatt hours to play with, and you might really only need 10 kilowatt hours, and how much are we assuming gets reserved, and what's possible, and really the conclusion I reached is, once you, and this is driving me to think about a pickup truck, which I haven't had in a very long time, because you can get the Ford Lightning with 24 kilowatts of V2G, is that when people that have these vehicles are increasingly going to be 100% flexible load. Like, it's just so much load, so much battery for a day, that you really can have quite an impact on your profile. So I think as that becomes more widely understood, it's going to drive some really interesting business models, and it's a really exciting time to be involved. But I think if we're not planning on really diving deeply into the opportunity of V2G and all this battery storage, we're really missing, it dwarfs all the utility scale stuff. It's a big number. Hamid, how electric power companies can affect the chargers distribution profiles? How can a battery storage system distribution affect distribution of chargers? Well, like I was just saying, you've got a lot of flexibility. What we found matters is really when you are plugged in, and that's how we develop our algorithms. Okay, robot, you have to have this much charge by this time period, and then for the rest of this time period, we want you to either pay attention to the price we're given, the tariff, the rate, or be paying attention to the spot market for the retailer service contract we have, or for the network charges, or possibly for peak demand on the local asset. And those all have very radically different profiles. And that's maybe actually something that would be a good webinar in the future, walking through what those different profiles look like, because they are pretty interesting. So that's all we have for questions today. Might give it another minute, but I wanted to thank everybody for your time today. Thank you for the great questions. Hopefully you've learned something, and if you ever want to talk more about this topic, just reach out. And I think the other thing I would plug is the next webinar is going to be looking at building electrification, some of the work that we did in Victoria, and the implications for other states, and really what we think is the potential impact on the grid. And we look forward to seeing you there. And we just got one last question from Oliver. Thank you. Is this available online? More material background info. This webinar will be available online, as will the presentation. It will also be sent to you via email. And in terms of this, like some of the work that we've done here, I think it was in the original email. The work that we did for Fresno Council of Governments lays out much of this methodology, or at least how it was 3 years ago. Other work that that's currently in train, and those publications are not released yet, but when they are, they'll be posted to our website. Well, here we are. I think we are pretty close to the 45-minute target that I was hoping we'd get through this all. So again, thank you so much for attending, and we look forward to seeing you next time. Bye for now.